In this segment, we're going to talk about techniques for extractive summarization and start off with some kind of classic techniques in the area. So the way we're going to formulate this problem more formally is that we are given a collection of articles. And so we're going to start by thinking about the multi-document case. So these articles are all on the same topic critically. Like they're all going to be talking about the same event, like an earthquake or whatever. And we want to produce a summary that has the most salient information from all of them. And we're also given a length budget of k words. So what we want to do is we want to pick some sentences of length at most k in total and make a summary out of them. So the kind of rough idea here is that we need to pick stuff that's important but also diverse. So we want to emphasize the key facts, but we don't just want to say one key fact over and over again. And so one of the earlier formulations of this due to Carbonell and Goldstein is what's called maximum marginal relevance, or MMR. And so here was their formulation of it. Basically, they said, all right, as long as the summary is less than k words, we're going to add a new sentence to it. And so what they're doing here is they're saying, all right, we're going to look argmax over all sentences that are not yet in the summary. So R is the sort of document collection, and S is the summary here. And we're going to compute the quality of a summary as a function of, or a sentence, sorry, as a function of two terms. The first is a similarity between that potential sentence and a query. So they're thinking about the task of so-called query-focused summarization, but there's ways around this where you can have the query be some kind of just like generic, basically just descriptor of the documents, and you can implement the similarity function in different ways. And then second, they have this idea that the sentence needs to be maximally different from all the other sentences so far. So you look at all the other sentences in your current summary, and you want to make it look dissimilar to the most similar sentence with it. And then after this process returns to you a sentence that should ideally have a mix of good new content while not overlapping with what's already here. And then we add one that doesn't, that doesn't kind of blow our length budget. And then we repeat this process. So we'll keep adding sentences until we get up to, up to k, or we can't add any more without going past k. So this is a kind of general template, or sort of, it shows a set of ideas that are going to show up again and again throughout these techniques. So a related technique is what's called the Centroid method. So we can basically compute bag of words vectors using TF-IDF for the document and each of the sentences in the documents. And so we could take the same approach where we're going to loop over, we're going to iterate, do an iterative process where we're going to build up a summary. And the way we're going to do that is we're going to score each sentence based on the similarity between the sentence vector and the kind of overall document vector. So does the sentence vector seem like it's kind of representative of the average content in these documents? Is it close to this centroid? And then in order to handle the idea of marginal relevance, we're going to throw out any sentence which is too similar to something already in the summary. So as opposed to the previous slide where we had these two scores that kind of traded off, here we have like a discrete threshold. We just say, okay, if it's too similar to something, throw it out. And then we want to take the best sentence that is left after this filtering process that, again, won't overflow the summary, won't go past our length budget of k words. Okay, so the idea that this kind of leads to is wanting to do some kind of optimization over selecting good content while not being redundant. And so we can actually formulate this in a little bit of a more principled way using a technique called integer linear programming. So the way that these techniques work is they typically ground out in the importance of certain bigrams or pairs of words in the documents. And so One way we can ascribe importance to word pairs is just by counting the number of documents they occur in. So maybe we have 5 documents about this earthquake, and 3 of them describe it as a massive earthquake. 2 of them talk about 6 people being killed. 2 of them talk about it being magnitude 7.3, etc. And then what we want to do is we want to find a summary that maximizes the score of bigrams it covers. So note that this naturally gives a notion of importance. We want to capture the high-scoring things that show up in a lot of places, while also giving a notion of content relevance, right? Or sort of non-redundancy, in the sense that if we cover massive earthquake several times, we actually don't get more points for it. We only get points for the first time we cover it. So the way that Gillick and Favre did this was to formulate this as an integer linear program. And so this is a technique that we haven't talked about in this course and isn't really going to show up much elsewhere. So I'm not going to go into it in too much detail. But basically, you define a bunch of, you define an optimization problem over a set of integer valued variables. And here their variables are about whether or not each bigram and each sentence is included in the summary. And so what you want to do is you want to maximize the weights of bigrams that are included. So these WI values come from the scores at the top of the slide, and the CI is a 0 if the bigram is not in the summary, and a 1 if the bigram is in the summary. And then we have a length. Our length constraint can also be expressed in terms of these variables, where LJ is the length of the jth sentence, and SJ, which is one of the variables we're allowed to tweak, is either 0 if we're not including the sentence, or 1 if we're including the sentence. Okay, so we have these C's and S's that we can change basically to try to optimize this objective subject to these constraints. But there have to be constraints between this, right? So basically, in order for a bigram to be included, it has to be the case that we're including some sentence that contains that bigram. So these 2 expressions here about S, Oc, IJ, and C are basically relating sentences to the bigrams that they contain and vice versa. And they're saying that, we're going to include CI if and only if some sentence that includes it is included in our summary. Okay, so basically the big drawback of this technique is that it places a lot of emphasis on these bigrams, right? And so you might be thinking, okay, what if one document said massive earthquake? What if one said large earthquake? What if one said, bad earthquake, whatever. And then we wouldn't see repeated mentions of the same bigram. Wouldn't this be a problem? And the answer is yes. This technique tends to work best when we have large numbers of documents in our collection, maybe at least 20 or something like that, so that we can start to reap the benefits of seeing actually bigrams get repeated. Of course, in a single document summarization setting, you would need a different way to score bigrams because, certainly the number of documents a bigram occurs in is not a good indicator. And even within a document, you're probably only going to say massive earthquake once in a lot of cases. Okay, so we've now seen a few different techniques, ranging from kind of greedy algorithms that aggregate information to this ILP-based technique, which is a little bit more principled, that formulates this as optimization. So how do we evaluate summarization and think about how these things compare? So the primary metric that gets used is a metric called Rouge. And Rouge is basically captures n-gram precision recall in F1 in a way a little bit similar to the BLUE score that we saw for machine translation, although BLUE was just precision oriented. So Rouge looks at all of these things, and there's some other tweaks to it. It's actually a relatively sophisticated metric in that it has a lot of things or a lot of flags that you can pass into it for things like stop word filtering, etc. But the takeaway is that Rouge 2, so looking at precision recall in F1 of bigrams, actually kind of correlates decently with human judgments in multi-document summarization. And so this is encouraging in that we just saw a method that's based on bigrams, and if we're trying to maximize basically covering bigrams likely to be in the reference summary, and then this correlates with human judgments, that indicates that this technique that we just saw may work reasonably well. So, to just kind of illustrate what's going on here, we have a sentence that we'll call our predicted summary and a sentence that we'll say is our reference summary. We'll just look at one sentence for each. So let's throw out the stop words. And then to assess the Rouge 2, we look at the different bigrams and we say, okay, what was the, what bigrams matched between the prediction and the reference? In this case, Iraq Sunday as a bigram. So we deleted on, right? So that word pair is going to now be next to each other. And we had 4 bigrams in the reference. All right, and so in precision, again, we get 1 correct bigram over 6 in the over 6 bigrams that we see in the prediction. And so, there's a lot of, like I said, there's a lot of different flags that we might pass into this, or different kind of options. But this gives you an idea of how this gets predicted, and I think it also gives you an idea of the fact that these results can be very low while still having a reasonable summary. So historically, what happened was people would look at, basically with a budget of size K, how good is your recall? And now people look more at Rouge F1, and we don't really need to go into the reasons for that. It's largely sort of historical, just trends in how stuff is evaluated here. Okay, so now with the appropriate kind of background, we can look at some Rouge results and try to understand how these systems are doing. So here's a comparison of some of the different things that we saw along the previous few slides. And the first thing you'll notice is that Rouge 4 is really, really low. So this is out of 100. So it's 1.72 out of 100 for this Gillick and Favre system, which is the ICSI system. But the kind of takeaway here from this paper by Galandri in 2017 is that actually a lot of these sort of relatively basic techniques can work pretty well. So they showed a kind of improved version of the Centroid method, which we saw a few slides ago, was able to basically match or exceed the performance of a lot of these fancier things based on like submodular optimization or determinantal point processes and things like that had been proposed more recently. So the one caveat I'll give is that all of the stuff we've been talking about so far is pretty much fit to the multi-document summarization case. So when we think about things like these bigram-based techniques that rely on counting up bigrams, again, it relies on the fact that there's going to be a lot of redundancy across these documents. So that helps us do content selection because we can look for what's redundant, and that's a very robust queue. And also, when you have a lot of documents, there are more sentences that you can extract, right? So maybe you would have this sentence that talks about the 8 villages being damaged, but it's very long and it's going to run out of your word budget and has a lot of stuff that we don't care about. But in another document, maybe we have this great sentence that is very direct and kind of states the information that we need. So we can pick up this second sentence, and this maybe leads us to the conclusion that multi-document summarization might be a bit easier. So I'll say the answer to this is yes and no. There are certainly kind of advantages to working in a multi-document setting, and there are some things about single document that are more challenging. But this sets up some of the challenges that we're going to look at. So first, we're going to talk about some more updated neural methods for doing this kind of extraction, and we're going to focus on these in the single document case. And then we're going to talk about compression. And so compression is going to be another way to say, all right, we've got this but 8 villages, blah, blah, blah sentence that's got a lot of information in it. And how can we delete some of the stuff that's less useful in order to get a shorter snippet, kind of like what we're seeing in the second sentence, so that we can include that in the in the summary, even if the second sentence weren't available. But this concludes our tour of extractive summarization methods, the kind of classic techniques used in the multi-document setting, and that's the end of this segment.